Okay, so in this video, I'm going to introduce something you may have heard before. I don't know. This is called Pascal's triangle, and let me show you kind of how how you continue making it, and I'm going to show you a couple of little neat things about it. Anyway, so what we start with is obviously ones down the diagonal. So the next row is also going to have more ones down the diagonal. So the way it works is 1 plus 1 is 2. And then you add these right here. 1 plus 2 gives you 3. 2 plus 1 gives you 3. So if I want to make the next row, it's going to be 1 plus 3 is 4. 3 plus 3 is 6. And then 3 plus 1 is 4. All right. So I guess one thing to notice is that the number of numbers, it goes up by 1 each time. We'll do a couple more rows here because we're going to need them. 1 plus 4 is going to be 5. We'll add these two. 4 plus 6 is 10. 6 plus 4 is 10. And then 4 plus 1 is 5. And then you still have that 1 there at the tail end. All right. 1 plus 5. So 1 plus 5 is 6. 5 and 10 make a 15 here. 10 and 10 make a 20. That makes a 15. 5 and 1 will make a 6. And then you get your 1. Anyway, this triangle technically goes on forever. I mean, you could keep replicating this little pattern here. Now, we're going to be using it in the next videos to multiply out binomials. So I'll show you what that does. But right now, I just want to show you a couple of neat little things about it. So if you look at the diagonals here, 1, 2, 3, 4, 5, 6, this continues to give you all the counting numbers. All right. The next diagonal here, 1, 3, 6, 10, and 15. These are what they call the triangular numbers, which means that you could draw them, and make a nice little triangle out of it. So like if I had 3 dots, that makes a perfect triangle. If I had 6 dots, right, it makes another equilateral triangle. And with 10 dots, I could do it again. All right, that's so you get all the triangular numbers there. Let's see here. What else do we got? If you add up the rows, so 1 plus 1, that's equal to 2. 1 plus 2 plus 1, that's equal to 4. 1 plus 3 plus 3 plus 1, well, that's 4 plus 4. That equals 8. Hopefully you can already see the pattern. 2, 4, 8. The next one is going to be 16. The next one, it's going to be 32. You got 20 out of those, plus that makes 30, and then 32. You get all the powers of 2. 2 to the second power, 2 to the third power, 2 to the fourth power, and on and on and on. What else is there? There's what they call the hockey puck thing. So if you, not a hockey stick. So if you start at one of these diagonals, I'm going to start right here at 1. And I'm going to start going along this diagonal right here. Now, I don't have to stop here, but I am. Right? If I stop here and add up these numbers, 1 plus 3 is 4, 4 plus 6, it will always equal that number off to the side from it. Makes kind of a hockey stick. Hopefully you see that. If I were to go, I don't know, let's say I were to start here at 1. 1 plus 4 plus 10. All right. 1 plus 4 is 5. 5 plus 10, it does give me this 15 here. I kind of have to stop where I'm at because I didn't want to draw even more rows, but it has applications in probability. Man, I don't know if I want to go into that right now, but let's say you had 10 people and you wanted to choose 5 of them to make a basketball team. It shows you the number of different ways that you can, number of different basketball teams that you can make from that group of 10 people. There's the prime number divisibility thing. So let's say you have a prime number that shows up as your second number here. So like 3 is a prime number. All right, it guarantees that all the other numbers in that row are multiples of 3. Okay, and it only happens with prime numbers. So like 5's a prime number, and so all the other numbers in here are multiples of 5. But if you got down to a non-prime number, like the number 6, 15 and 20, 15, these are not multiples of 6. But it guarantees that you're going to have a bunch of multiples of that prime number if your row starts with that prime number. All right, guys, that's good for now. Get ready. We're going to do some math next.